special circumstances. There's more silicon on the surface of Earth than carbon, and yet, the life here is carbon-based, not silicon-based. Underneath you have germanium. Not too many science fiction stories talk about germanium-based life, and under that is tin. Well, there was the Tin Man in the Wizard of Oz, but then lead. Well, okay, so carbon-based, we assume that, and then there are a whole bunch of other things. Homochirality, that the molecules are preferentially one way rather than the other. They're on a planet with plate tectonics because otherwise they can't have technology because they can't get to the heavy metals they need for technology. A big moon to stabilize the rotation of their planet so that the poles don't come down and wreck everything all the time. Some big world nearby. These are essentially the things that are talked about in Rare Earth, that book from 2000. Bigger than rats, smaller than 10 elephants. These are just scaling laws, right? Can wield a soldering iron. Stereo vision, that's helpful. These are the kinds of things we just implicitly assume. Here are a few more. These are the implications for the planet, right? It has liquid water, some sort of atmosphere. It's not too young. It's had enough time to evolve not just life, but intelligence. Okay? And these are exactly the kinds of worlds that Kepler is looking for. Analogs to Earth, cousins of Earth. If there's one question I've gotten more than 50 times in the last 2 weeks, it's, so if Kepler does find many dozens cousins of Earth, will you turn your antennas in the directions of those planets? And of course we will. Of course, if they can be reached from the Allen telescope array, of course we will do that. But do keep in mind that finding a few dozen is really not the point. What you want to know is what fraction of stars have those kinds of planets, because finding a few dozen doesn't really improve your chances all that much. Think of looking at the Earth. Earth has had life for, what, 4 billion years? Those of you who have been reading the papers that long know. So 4 billion years, but over what span of time could you look at the Earth and actually find somebody who had a radio receiver, so paid to send them a message? Right? Only in the last 100 years, out of 4 billion. So you really need a very, very long list of Earth-like worlds before it's reasonable to assume that some of them have intelligence that might be broadcasting to you. So getting, 50 new Earths, wonderful, but that may not affect SETI, except that it tells you, hey, 1 in 10 stars has an Earth-like world, or 1 in 100, or maybe the number is very much smaller, right? If the number is very much smaller, if Kepler fails to find Earths, well, that's discouraging news, but it's very important for SETI. The important thing is the fraction, okay? But in any case, we continue to look for Earth-like worlds. Well, I'm here to tell you that maybe that isn't the way to go. I'm going to skip this. It does assume that they're somewhat like us. That's the assumption. Now, when I say somewhat like us, let's think about that for a moment, because there's a time scale argument here, right? We've been on this planet. There's been life on this planet for 4 billion years. In the last 200,000 years, we evolved Homo sapiens. In the last 100 years, we've evolved the capability to make our presence known by broadcasting into space. What's going to happen in the future? Because that's important. If you find ET, remember, you're not going to find the ETs that are less advanced than we are. Because they're not building transmitters, right? There may be plenty of extraterrestrial Neanderthals or trilobites or dinosaurs or whatever, but they're not clever enough to build a transmitter, so you can forget those guys. The only ones you're going to find are the ones that are at least at our level. And statistically, if L in the Drake equation, for example, is very long, thousands and thousands of years, then statistically, they're going to be ahead of us by at least hundreds of years, thousands of years, maybe millions of years, maybe billions of years for that matter. Okay, so they're going to be ahead of us. So it pays to think about what we are going to do. How are we going to evolve? Because that will tell you something about ET. Well, one thing we'll probably do is, we'll put cybernetic enhancements in us. One guy was talking to me the other day on our radio show, some guy in England, who pointed out that, we're soon going to have a little chip that you implant somewhere under your skin that will, give you instant access to all the information on the internet, which might improve, your conversation at parties, I don't know. But also a lot of your personality will be downloaded into it too. And I asked the guy, I said, does that mean that if I'm going to dinner with somebody that, 99% of my appeal is in that chip? And he said, well, yeah. He said, but look at the bright side, Seth. He said, what it means is that when you die, that doesn't really affect your job performance very much. That was his take on it. Okay, so we're going to do all this stuff. All right, so maybe ET's already done, and they got cybernetic enhancements, but that doesn't change anything very much in terms of SETI. This, however, does. This is one of many of the plots made by Hans Moravec of Carnegie Mellon, and you can find these on his website. This is an old plot now, but I don't think he's updated it. So laser pointer, we can use this. Okay, so it's how much compute power you buy for $1,000 since 1900. And when the data here end in 1997, you buy the compute power of a spider for $1,000. I don't know if that interests you. Today, you'd be up here somewhere. So today you buy the compute power of a lizard for $1,000. So if you're selling car insurance, maybe that's... But the point is that by 2020, see, your desktop computer will have the same compute power as you. I think most of you know this now. Your desktop, your laptop will have the same compute power as a human brain by 2020. There's very little doubt about that. It'll also have a lot more memory, by the way, and it won't forget things. Okay, now, that isn't to say that it's going to be thinking. That depends on the software. But there are a lot of people worrying about software, right? Now, you know, what's the usual reaction to this is one of horror. You mean that my job's going to be in jeopardy because by 2020 the machine will be as clever as I am? And I think the answer to that is, well, yes. But, and my personal reaction to the whole thing is I'm just going to turn the keyboard around, you know, you type. Some people worry about this. Maybe you should worry about this. I mean, Ray Kurzweil writes books about this. He sees it all as a good thing. Many people think of it as a good thing. Some people think of it as a bad thing. But in any case, it's a thing. And it might not happen by 2020. We may not have thinking machines by then. Maybe it takes till 2030. Maybe it takes till 2050. It doesn't matter. What if it takes till 2100? Doesn't matter. Doesn't matter. It's very fast. And once it happens, there's no more competing. Right? All those little chips in your body to make you interesting at those cocktail parties don't matter. And so I made this little graphic to sort of dramatically show what I'm talking about. Here's a horse 60 million years ago, about the size of a collie. Okay, here's a horse today, about the size of a horse. Okay, so that's 60 million years. On the right-hand side are just some personal computers. I had a personal computer in 1977. It wasn't this one, but something like it. It had a clock speed of 1 megahertz, 8080 chip. So 1 megahertz, my computer today at home has a 2 gigahertz clock. So it's 2,000 times faster in 30 years. 2,000. This is what nature does in 60 million years. Makes a horse a couple of times bigger, that's it. Okay? So the point is that once you have a machine that's as good as you are, within 20, 30 years, your desktop machine is now as good as all humans put together. Right? Now, you know, the question comes up, what happens to us? Do we become their pets? Do they exterminate us? Do they just leave? What? I don't know. I mean, you can think about that. But the point is that if this is going to happen to us, it's already happened to them. So this is a timescale argument. And once you have artificial intelligence, there are all sorts of advantages to artificial intelligence that don't accrue to biological intelligence. I think you can just forget these guys, which look a lot like us, all right? And consider that the real successors are going to be some sort of machinery. Again, if you don't get anything else out of this, consider this time scale argument. You take a planet that cooks up life. It takes 500 million years, maybe a billion years to cook up life. And then it takes another 3.5 or 4 billion years to cook up intelligence. Right? 200,000 years after that, it cooks up technologically competent intelligence. At that point, you invent radio, and within a few hundred years, you invent your successor. So the point is these time scales, that as soon as you go on the air, almost immediately, you develop something that succeeds you in terms of intellectual capability. Right? And indeed, that presumably takes over. It doesn't have to stay on a planet like ours. Okay? I mean, it may be, I can imagine there's tremendous intelligence out there. Maybe some of it remembers, yeah, there was some sort of dirty, messy, biological start to all this. I think it's in the archives somewhere. It's sort of like you thinking about the wheel. You use the wheel every day, but you don't think much about the guy who might have invented the wheel, right? It's so far back. Okay? Now, what would this artificial intelligence be like? Because if this is the dominant intelligence in the universe, maybe that's what we should be looking for, instead of looking for the biological intelligence, which has such a short run. Right? That's what our SETI experiments do. Well, some say that it'll be the nanobots. Ray Kurzweil himself, who was at the SETI Institute a couple of weeks ago, was going on about nanobots. They'll take over, and of course, they'll spread out to chew up the cosmos, or whatever it is that the nanobots have on their little diminutive brains. You get the gray goo meltdown. The whole universe turns into gray goo, chewed up by nanobots. I don't know if this will actually happen. This seems a little strange to me. You can think of insects. Insects are sort of nanobots, and you go out and look at the foliage around this hotel, and all of it has been chewed up a little bit by